I want to talk a little bit about a project which I founded and which we're bringing to the CD Foundation. But first, I want to kind of back up and talk about why do we actually need more security software, and how does this affect the sort of systems which we all build. So I think if you're working in a technology company, you know that over 80% of the software which most big companies use is open source software. So you're depending upon open source libraries, you're pulling in dependencies from different central repositories, and this accelerates development. It helps you to build faster and to contribute back, but it also introduces a certain amount of risk when you have zero-day attacks, when you have security exploits and other things which are coming. And I think if you weren't already popular for being a software developer or for working in the technology industry, now your grandma, your parents, everyone will hear about you in the news with the latest incident, whether it's the Log4j attack, the SolarWinds exploit, which kind of made headlines. This introduced a whole bunch of legislation from the government, such as the Biden administration's new security mandates. There's a new HR 7900 bill which just recently came out, which requires you to secure software and provide that there's no security vulnerabilities in software you're selling to the government agencies. And even incidents like Log4j or Log4Shell impact our industry. So who had to patch a production system beginning of last year? Okay, so quite a number of folks. Either you or your teams who were doing it. And these are the things which are really just the tip of the iceberg for what's happening with security exploits. So how many folks use software from one of these areas? NPM, PyPy? Okay, if you're not raising your hand, you're not a developer. And we trust all of these central repositories for where we get our information, but there are a lot of vulnerabilities which they expose us to. And one of the vulnerabilities which came out is the dependency confusion attack. This was popularized by Alex Bersan, but actually it was known as a potential exploit for much longer than this. And basically the way this exploit works is you let's say you're a company and you have your awesome corporate lib version 1.2. Somebody else, such as Alex, publishes awesome corporate lib version 6.6.6 in a central repository, and your vulnerable package manager goes and retrieves the latest version, and it goes and it sees, aha, actually the latest version's out there in the public, and I'm going to pull that version. And it's slightly worse than this as well. So in particular, like the way NPM works, it also advertises when you go to NPM and you request a package, it advertises what you're requesting. So you can also intercept and you can figure out what the namespaces are for internal corporate libraries. And this is very bad stuff because you never want to be pulling your corporate libraries from an external source, and bad stuff happens when the big red button gets pushed by little kitties. Okay, so this is the dependency confusion attack. It's easy to patch now if you're using a package manager which blocks you from this sort of attack like Artifactory. And this netted Alex Bersan over 130K from various US corporations. So he a whole bunch of companies, I think it was Facebook, Apple, a whole bunch of different large corporations, where he basically did bug bounties simultaneously across dozens of organizations and collected it all for the same bug. So you would think this is an isolated incident, but just recently our security team found a whole bunch of packages published to NPM, and they're basically doing a typo squatting attack on not putting the namespace prefixes on Azure. So if you're using any of the Azure libraries, so core tracing, Azure tools, Azure tests, Catalang was also targeted. If you use any of these libraries and if you forgot the namespace prefix, or if your ID shortened it, then you'd be pulling down a malicious library instead of the library you're expecting to get. And they also cleverly did this where they set up a bunch of fake user accounts so that there was no correlation between the different libraries which were uploaded. So we reported this to NPM, all the vulnerable packages were taken down, but this is another example of bad actors taking advantage of poorly designed systems from a security perspective that we all rely on. And anybody want to take a guess at how many vulnerable packages our security team has found in NPM to date? Just round numbers, throw something out. In the back of the room? 100,000. All right, 100,000, that's high. 2,000, okay, that's low. So the actual number, and I confirmed this last week with our security research team, is 17,000 vulnerable packages so far. And it is quite easy to upload things to NPM, to upload things to PyPy. They don't enforce namespaces. They don't enforce kind of the common things which you'd expect them to from a security perspective. Okay, so hopefully we can do better. And one of the goals of Pyrsia is to create a more secure way for us to distribute open source, for us to secure the open source supply chain, and to do that in a like collaborative community open source way. So this project is designed so that it was always intended to be donated to a foundation. So we're very, very glad that the Continuous Delivery Foundation is a very good home for us. The name Pyrsia has Greek origins, so it comes from the word fire, pyro, and this was an ancient Greek system to communicate over mountaintops. So they would have 10 torches, they would line those up with the grid for the alphabet and then be able to communicate letters. And when we think of Pyrsia, we want a system that's very reliable. Even central repositories going down, like outages in NPM or PyPy or Maven Central, those are like big denial of service attacks against the open source community. You can't do your builds, you can't get things running. We want something that's secure, that enforces proper namespaces, that builds from source, that provides security guarantees that you can start to make so that you know the provenance of the artifacts which you're using. And something that's open, that's fully open source solution. You can inspect the code, you can make sure that it works well. We'll talk later about the design of the code itself. And the way we accomplish this is, first of all, building it via peer-to-peer network. So the Pyrsia network is designed to be fully peer-to-peer. We also do builds where we're building not just from one company or one company's infrastructure. We're doing builds across multiple companies, and we're verifying those builds against each other to ensure that the basic guarantee you get from the Pyrsia network is when you download something, it will be the same artifact that you would get if you built it yourself from source code. And I think this is a really important guarantee because it avoids supply chain attacks like what happened to SolarWinds, where after you do a build or in the build process, in their case, they got in the network for the company, and then it doesn't matter what their CI technology was, but they're using TeamCity, and then after the build, they injected the malicious code right before the signing process. So if you built their code from source, in their case, it was proprietary, not open source. But for an open source project, if you build from source, you want to get exactly the same results out of the network in which you're downloading as if you built it yourself. And the last key component of this is a immutable transaction ledger, so that you have that full traceability into who signed it, who's built it, who's verified the images and what you're building. And then you can layer this into software bill of materials and other downstream security systems where you need to guarantee the code base. So we're not doing this alone. There's a whole bunch of companies which are collaborating together with JFrog. So, of course, I work at JFrog. We have great support from Docker, who's collaborating with us on this. And one of the first ecosystems we're supporting is downloading Docker packages, Docker image files from the network. Deploy Hub, Steve Taylor has done a lot of tremendous work on the project, so I'll also chat with him. Huawei and FutureWay have been great as well. So David, who's on the board, has been supporting this. And then Eric Sedler from Oracle is our sponsor there. So we have a lot of great companies who are contributing. We're looking for more people who want to join the project, to run an authorized node, to help us with the build from source, and to make sure that this is a distributed, open network where it has a lot of the ecosystem represented. And that makes it a very hard attack surface for attackers and hackers who want to compromise the network. So hopefully this taught you a little bit about what we're doing at the Pyrsia project. We'll get you excited to either try it, to use it to download your packages, or to contribute as a company. And I'm very pleased to be able to open up the CD Summit and watch all the great presentations today. So thank you.